Hi, welcome. Today we're going to be reviewing how to simplify rational expressions. We're going to use the LCD method. Now we're also going to be using this tool to be solving for rationals. Now the one thing we can't forget about today are domain restrictions. That's if you have any variables on the bottom. So let's go ahead and get started. We have our first equation, or first expression here, x plus 2 over 3 over 6 plus x minus 4 over 3. And to get the LCD, we should know this from elementary school, right? You know, what's the common denominator for 6 and 3? It's 6. And if I want to write my fraction, I'm going to put it over my common denominator, which is 6, and I'm going to find out which one is it missing. Now, this 6, it's already 6. So that means the x plus 2 stays the same. But the 3, it needs to be multiplied by 2. So that means I have to multiply the top by 2, and I get 2 times x minus 4. I find out what it's missing. So when I simplify here, I get x plus 2 plus 2x minus 8 over 6. And if I simplify this, we get 3x minus 6 over 6. And if you notice, I can even simplify this further if I want to, because they're all divisible by 3. So divide 3, I get x minus 2 over 2. You got to divide everything by 3, though. So if we take a look at a problem like number 2, let's get our LCD, the least common denominator. Well, the simplest way to get the least common denominator is to just multiply together. So x, y, that's my common denominator. So when I write my fraction here, I get x, y. Now, on top here, I take a look. Well, the 4, it has the x. The 4 is missing the y. So I have to multiply that 4 by y. Minus the 5, underneath it, it has the y. It's missing the x. So I have to multiply that 5 by x. And there's our answer. Now, we do have a domain restriction here. We actually have 2 of them. Weird. X can't be 0, and neither can y. So there's our domain restrictions. So let's take a look at a question like number 3. Same way, I look for the common denominator, and the easiest way is to just multiply the denominators together. If you're unsure how to find a common denominator, multiply them all together. So I get x minus 1, x plus 1. Write my common fraction. I'm going to get x minus 1, x plus 1. And I ask, the x, it has the x minus 1. On the bottom, it's missing the x plus 1. So I have to multiply the x by x plus 1. Minus the 1, it has the x plus 1. It's missing the x minus 1. And then I just simplify. On top, I get x squared plus x minus x plus 1. X's cancel, so my final answer, x squared plus 1 over x minus 1, x plus 1. And there is our answer. Please, we cannot cancel the x squared plus 1s here. We're not allowed to cancel those, okay? Even though they look the same, the square makes a big difference. We do have 2 domain restrictions here. X can't be 1, x can't be negative 1. Very easy to do these. Alright, number 4, they get a little bit more challenging. So, I am going to factor. Anytime you can factor in math, you should. We always like factors. Here, get a difference of squares, right? X minus 1. And now let's talk about the LCD here. The LCD on this one is a little bit tougher because if you notice, they actually have a common factor down there. And that's going to be the first thing I pick. What they have in common is the x minus 1. And now I take a look. Whoops, oh, that should be an x plus 1. Sorry. What they have in common is they both have the x plus 1. I'm sorry. They both have an x plus 1 there. Now, after I find out what they have in common, they get the least one. Now I'm going to take a look at what they don't have in common. This has an additional x plus 1. So I have to include that one. This one has an additional x minus 1. So you're going to take a look at what they have in common, and then you can look at the extras. What's left over. So when I rewrite this, my common denominator it's going to be x plus 1, x plus 1, x minus 1. Now my top is very easy. Now take a look here. The x squared plus 2x plus 1, it has both the x plus 1s. What's it missing? The x minus 1. So I take this 1, multiply it by x minus 1, minus 1. Now the x squared minus 1, it has the x plus 1, x minus 1. It's missing the another x plus 1. So that's what I got to multiply by. And if you simplify the top, we get x minus 1 minus x minus 1. X's cancel, and we're left with negative 2 over, and if you want to, x plus 1 squared, x minus 1. Number 4, you may want to try that again before you move on to the next section, because this is as hard as they will get. Alright, so where do we use this? We use them when solving. Okay? Solve the following by finding the critical numbers. Now, if you remember what a critical number is, remember a critical number is where the function equals 0. Or, what we're going to talk about tomorrow, or where it could not exist. So we're going to talk about that tomorrow. Now, so if I take a look here, oh yeah, yes, I know what you guys are thinking. We didn't do the domain restriction over here. We do have domain restrictions. We can't be negative 1 or 1. So, let's take a look at number 1 right here. If I want to solve this, the first thing I'm going to do is I'm going to find a common denominator. Okay, for all of them. My common denominator, very easy. What will number? We'll go into 3, 5, and 4. Okay. I'm not too sure, but I know 60 will. So I'm going to use 60. So I'm going to make two sides of my fraction. Both of them will have a common denominator of 60. And we'll talk about why we like that in just a second. The x, well, to get 5 to equal 60, we have to multiply by 12. So that becomes 12x minus, and to get 3 equal to 60, we have to multiply that by 20. To get 4 equal to 60, we have to multiply that by 15. Now, why do we like the common denominators? Because they go away. If you were to cross multiply, the common denominators go away. They just divide out. So it's basically this. If the bottoms are equal, then the tops are equal. So now I can just write this as 12x minus 20 equals 15. 12x equals 35. X equals 35 over 12. Very easy to do. So if I take a look at number 2 here, let's find the LCD. Now, I take a look. None of them have anything absolutely in common, but if you notice, these two both have an x. So part of my common denominator is going to be an x. And what do you think the other one's going to be? Ah, these both have a 3, so I'll make it 3x. Very good. So I write two fractions. Two fractions. Okay? They both have to have 3x underneath it. Now, this 3, it has the x. What's it missing? The 3. So I have to multiply by 3. Minus, now this 3x, it has them both. So that's not going to have any. The 2, it has a 3 on bottom. What is it missing? That's right, the x. So what do we wind up with? Over here, we get 9 minus 1, so 8 over 3x equals 2x over 3x. Don't reduce. We'll talk about this in just a second. Now, we do have to be careful. We do have a domain restriction. And to get that, we have to go way up here at the beginning. X cannot equal 0. So, now, if I wanted to solve this, again, are the bottoms equal? Check. And if the bottoms are equal, guess what that means? The tops must be equal. So I can just look at the tops. 2x equals 8, x equals 4. It is not my domain restriction, so there's my answer. So let's try number 3. Now I know a lot of you guys will say, hey, I can cross multiply. And you can actually get this one by cross multiplying, but why does cross multiplying work? It works because of the LCD. Watch what happens. What's my common denominator? This one has an x, this has an x minus 3. There's my common denominator. You just multiply them together. So we do have some domain restrictions here, so let's talk about those real quickly. What are the two things x cannot be? 0 or 3. Okay? Now, I'm going to solve this by writing two fractions. Over here, I get x minus 3. Over here, x and x minus 3. Now, the 1, it has the x. What's it missing? The x minus 3. The 2, it has the x minus 3. It's missing just the x. So now we kind of see how cross multiplication works, because what's going to happen is I would multiply the 1 by the x minus 3 and the 2 by the x, and we see that. And this is why cross multiplication actually works. Now, are the bottoms the same? Check. So what do I look at? Only the top. If the bottom are the same, we can just cancel those out, and I'm going to get this. X minus 3 equals 2x, so negative 3 just equals x. Not part of my domain. We're okay. All right, so go to part 2, and we're going to take a look at some more complicated questions in just a moment.